This is our last lesson in the first half of this unit. And this one is on multiplying polynomials, but this is going to be on some special cases. So some certain situations where we're going to pick up on some patterns and be able to kind of quickly work our way through some problems instead of having to write out all of the work. So the two we're going to focus on is the square of a sum or the square of a difference. So what's going to happen is in our first example here, 3a plus 4 squared. So the square of a sum, you're adding the two pieces together. Well, we talked about in class that square just means two of those binomials are being multiplied. 3a plus 4 times 3a plus 4. We follow our double distributive. So 3a times 3a is 9a squared. And then we do 3a times 4 is 12a. Then I do the same thing with my second term. I distribute it through. So 4 times 3a is 12a, and 4 times 4 is 16. So what you're going to notice in these special cases is we're going to kind of repeat that middle term. We get 12a and 12a because we did 4 times 3a and 3a times 4. We're going to do the same thing. So when we combine them, we're going to get 24a plus the 16 plus the 9a squared. So the pattern we want to notice is the first term is my first term squared. 3a times 3a is 9a squared. So for our pattern, we're going to use the generic a and b. So a plus b squared. The pattern is my first term is going to be a squared. 3a times 3a was 9a squared. My last term in my example was 16. Well, that was just 4 times 4. b squared. And then my middle term was 12a and 12a. So I did a times b, and then I did a times b again. So I did 2 times those middle terms. So that idea of the first term is getting multiplied times itself, same thing as squaring. The last term is getting multiplied times itself, squaring. And then the middle terms are getting multiplied, but they're doing it twice. We have two of the same thing. So let's see how that shows up in this next one. 2z minus 9 times 2z minus 9. So again, following our double distributive, 2z times 2z is 4z squared. Then I'm doing 2z times 9, negative 9 is negative 18z. Then I'm doing negative 9 times 2z is negative 18z. And negative 9 times negative 9 is positive 81. So again, what's happening is we're getting 2 of that middle term. So this would simplify to be 4z squared minus 36z plus 81. So again, my first term was 2z times 2z, so 2z squared. My last term was negative 9 times negative 9, which was positive 81. So in my formula, I had a minus b, and a and b can be any size of a polynomial. It could be just a single variable, it could be a number and a variable, it could be a couple variables. It's just kind of a generic stand-in, the first term and the last term. So same rule. We're squaring the first term, we're squaring the last term, and because it was a negative times a negative, it's going to be a positive. In the middle, we're doing a times b, and there's 2 of them, but this time because of that negative in there, that middle term is being subtracted away instead of adding. So we're squaring that first term, we're squaring that last term, we're multiplying the two terms together, and multiplying times 2 because there's going to be 2 of them. We're kind of repeating that middle term. All right. A little awkward at first, but once you kind of get the hang of it, you start to pick up on the pattern and it goes a little smoother. So here, let's do a couple of them and then we'll start to pick up on our pattern. So 3p plus 4 times 3p plus 4. So I'm going to multiply 3p times 3p is 9p squared. I'm going to do 4 times 4 is 16. And then remember what happens in the middle. So in the middle, I'm going to do 4 times 3p is 12p. I'm going to do 3p times 4, which is 12p. So I'm going to get 2 of those 12p's in the middle, which gives me 24p for that middle term. I'm kind of repeating that. I'm doubling that middle piece. All right, so 4x minus 5 times 4x minus 5. I'm going to multiply those first terms. 4x times 4x is 16x squared. I'm going to multiply those last terms. Negative 5 and negative 5 is positive 25. But then the middle, I'm going to do negative 5 times 4 is negative 20x. And here I'm going to do 4 times negative 5 is negative 20x. So I get a negative 40x is my middle term. So we're multiplying the first terms, we're squaring them, multiplying it times itself, doing the same thing with the last terms, and then we're doubling that middle term. So let's try the next one without writing it out, without showing all of the work for it. But it is helpful to write it out to show what's being multiplied. So I'm going to start with 6h times 6h is 36h squared. Negative 1 times negative 1 is positive 1. And then in the middle, I'm going to get negative 1 times 6h is negative 6h, but it's going to happen twice, so that's going to be negative 12h. Again, until the pattern starts to kind of click for you, feel free to write out the work, to do the math and put them together. It's just that idea of as we get better and better at it, it will start to kind of speed up for us and we'll start to notice those patterns and be able to kind of do some of it without any of the work. All right, so 7w minus 3 times 7w minus 3. Again, first term, 7w times 7w is 49w squared. Last term, negative 3 times negative 3 is positive 9. And then think about what's going to happen to those two middle terms. It's going to be negative 3 times 7w, which is negative 21w. But there's going to be 2 of them, so we want to multiply it times 2. Negative 42w. All right, so that was when we were squaring the same term, either the sum of, or the square of a sum or square of a difference. Here, it's a product of a sum and a difference. So I'm adding 13 and subtracting 13. I'm going to cross that line out. We're not going to need that one there. So watch what happens here. Z times z is z squared. Z times negative 13 is negative 13z. 13 times z is 13z. 13 times negative 13 is negative 169. Now, look at those middle terms. Again, everything was the same about those two binomials with the exception of the sign. One was adding, one was subtracting. So I have minus 13 and plus 13. That turns to 0, and I'm left with z squared minus 169. Z squared was z times z. 169 was 13 times 13. One of them just happened to be negative. Okay? So that middle term dropped out because it was the same number, just one's positive, one's negative. So our pattern is, if we were to do a plus b times a minus b, look at what we were left with. We were left with a times a squared. We were left with b times b squared. And because of the different signs, it was going to be a subtraction. The middle term drops out entirely. Okay? So you're really squaring the first term, we're squaring the last term, and then remembering that it's subtracting because we had a positive and a negative version of that last term. Okay? All right, so let's try a couple of these here. So x minus 4 and x plus 4. So I'm going to get x squared for my first term. I'm going to get negative 16 for my last term, negative 4 times 4. In the middle, I'm going to get negative 4x and positive 4x, which is going to turn to 0x. So I just get x squared minus 16. All right, next one. 4x times 4x is 16x squared. Negative 5 times 5 is a negative 25. But I'm going to get a negative 20x and a positive 20x. So those are going to drop out. It's going to turn to 0. And I get 16x squared minus 25. All right, so if you start to pick up on the pattern, see if you can do these for yourself. Pause it and try them, and then see what you think after that. All right, so 5x times 5x is 25x squared. 3 and negative 3 is negative 9y squared. Remember, multiply the numbers, add the exponents and the variables. There'll be no middle term, so that one drop out. So 7k times 7k is 49k squared. 3 times negative 3 is negative 9. All right, bottom couple here. 4d times 4d is 16d squared. Minus 7 times 7 is 49. 3g times 3g is 9g squared. Minus 9h times 9h is 81h squared. Nice and quick, because we know those middle terms are going to drop out. All right, so it says Janelle wants to enlarge a square graph. Notice it's square, so we know all the sides are the same, so that the side of the new graph will be 1 inch more than twice the original side g. So the original side was g. We want 1 more than twice that. Well, it's a square. So the other side is also going to be 2g plus 1. Or you could think of 2g plus 1 squared. So this is our square of a sum. So if you remember back to the beginning of the lesson, we're going to square the first term. 2g times 2g is 4g squared. We're going to square the last term. 1 times 1 is 1. And then you remember the middle terms are both going to be the same. 1 times 2g is 2g. 2g times 1 is 2g. So I have plus 4g in the middle. And that's going to be the expression I could use to find the area of that new picture or new graph.